A very warm welcome to this, the first film in our Foundations series, in which we examine the fundamental principles of foundations. Buildings are erected on underlying supporting structures that are in turn placed on the ground on the surface of the earth. I'll explain exactly how this is done using the example of one of our projects. This photograph shows Stadtwerke Wolfsburg AG's new headquarters building. Due to its height and the way it stands out from the surrounding built environment, it's also known as the Nordkopf Tower. The structure underlying a building is called a footing or foundation. Foundations are designed to distribute the load from the structure above into the ground below. All the loads acting on a building, traffic loads, environmental loads, and the weight of the building itself, for example, are concentrated in the foundations where they are transferred to the ground. As we saw in the previous Structural Members series, loads are transferred from one building component to another, and so the contact surface between these components has a bearing function. In the case of foundations, this contact surface forms a critical interface between the structure and the ground beneath it, the structure-ground interface. The forces at work in the foundations act on this structure-ground interface. To satisfy the equilibrium of forces principle, the forces at work in the ground must therefore do the same. If the structure of the ground is sufficiently strong, this is exactly what happens. However, it's frequently necessary to apply force to the ground, that is, to compress it to achieve this equilibrium. As we've already seen, the sand beneath this litter bin is difficult to compress, and so the litter bin is in danger of sinking into it. To prevent this, the litter bin could be placed on a concrete slab. Rather than being concentrated in four thin legs that tend to sink into the sand, the load would then be distributed throughout the concrete slab, thereby reducing the pressure on the individual grains of sand. This is the fundamental principle of foundations. They must be large enough and so distribute the relevant loads over a large enough area to ensure that the ground is able to exert a counterpressure. How big this counterpressure must be depends on the allowable ground-bearing pressure for which the foundation is specified. Unless foundations are laid on solid rock, a certain amount of compression is required to achieve this bearing pressure. The ground needs to compact before it can counteract the load exerted by the foundations. This means that the structure-ground interface shifts and the building sinks very slightly. It settles in the technical jargon. However, settlement must be both minimal and even. Once the ground has compressed to the point where its counterpressure corresponds to the pressure exerted by the foundations, settlement is complete. This is exactly what happened beneath the bell tower of Pisa Cathedral, for example, though here settlement was clearly far from even. Uneven ground conditions can cause uneven settlement, as with the Leaning Tower of Pisa, which is believed to have been sited on the edge of an infilled harbour basin. Far more frequently, however, settlement is caused when buildings transferring different loads into the ground are constructed next to one another. This is what would happen if someone were to drag our litter bin to a beach bar and set it against the rear wall. Two such structures are normally separated by a joint that runs right through the foundation. This point was also covered in our Elements of Architecture film series. If the load-bearing capacity of the ground is insufficient, laying deep foundations and improving the soil can help. Piles can be rammed or bored into the ground, transferring the loads to the ground around them via their outer surfaces by friction or down to load-bearing strata at the end of the pile. Alternatively, it's possible to improve the allowable ground-bearing pressure by replacing or compacting the ground beneath the foundations. In some cases, the structure-ground interface may be subject to tension rather than compression forces. This typically occurs where groundwater or floodwater close to the surface causes the building to lift. One way to prevent a building from lifting is to reverse the effect of bored foundation piles so that the surface friction of the piles acts against the tension forces and so prevents the structure from being pushed upwards. Summary. The underlying structure of a building is called a foundation. Foundations are designed to transfer the load from the structure above to the ground below. Loads are transferred from the foundation to the ground, and so the contact surface between them has a bearing function. This contact surface is known as the structure-ground interface. Please take a look at the second film in our Foundations series. In it, we discuss the preparatory work that has to be carried out before foundations can be laid.